I have those questions that I have, I think just 3 of them. And what we're going to do is they're graphical analysis questions. So we're going to go through them together. And I'm going to give you some tips, okay? Some of the questions that I will be discussing, some parts, the way that the question, the way that they test you. Sometimes it's kind of similar. So I'll just be familiarizing you with some of the testing styles. So the first question says, this is a quadratic equation. So quadratic equation, if you just want to identify one, it will look like either a cup, or it will look like an N like this. Okay, so not necessarily like this. It will be a little bit pointed up, just like what you're seeing here, or it will be so like this. This one is more like it. It's called a parabola. Parabola, it's simply a quadratic curve. Okay, so the quadratic curve for this one, it's this function here. In the next question, you're going to see how we can construct such a function. But then right now we have it constructed for us, and then we just have to answer questions. Okay, so write down the turning point of the graph. Okay, so that's what you're asked. So this is the y-axis, this is the x-axis, and this is our graph. Okay, those gradations, they're kind of very simple. So here it's 2, so this one must be 1. So it just depends. The scale can be different for different graphs. Okay, so sometimes you also have to choose your own scale so that you can accommodate all the points that you need there, because sometimes they give you range. But anyway, you're asked to write the turning point. So points in Cartesian plane. This is Cartesian plane from René Descartes. So René Descartes. So this guy is the one who invented Cartesian plane. So he used it for identifying points on a 2D plane. So this one is 2D. It's going up as in y, and then it's going across as in the x direction. So whenever you want to describe any point, you have to describe it in this way. You have to put the x ordinate. This is called ordinate. Okay, and then you have to put the y ordinate. Together they're called coordinates. Okay, so the coordinates of that point, you have to define them this way. How much farther from the origin, this one is called the origin, do I have to go in the x direction, and how much farther in the y direction for me to arrive at that particular point. Okay, so your turning point here, it simply means where your graph turns. So your graph turns at this spot here. Okay, so you have to define this. You're here on the origin, you have to move 1, so this one intersects with point 1 on the x-axis. So your turning point would be 1, and then you also have to define the y. So the y would be negative 4. So the dotted lines that you saw me putting here, this is how you show that you know the working. Okay, so what you actually do in fact is to put a ruler. You'll be having your graph, so you put a ruler here, and then you'd write your points, and then you would put a ruler. You would put a ruler there. Okay, so you'd put a ruler again horizontally. Okay, then you'd write the other points again. Just make sure that your pencil is aligned. Yeah, but if you want, you can actually do it just by pencil, because you're just doing it's a broken line. Okay, those are broken lines. So you get this as your point. So you're asked to use the graph to find the roots of the equation. So the roots of the equation, our equation is x squared. Okay, sorry. Our equation is x squared minus 2x minus 3 equal to y. Okay, so what they did here was that they put it as x squared minus 2x minus 3 equal to what? Equal to 0 here. So that's what they did. They simply replaced y with 0. And so to actually find those coordinates, you have to find them on the point, on the line y equal to 0. That means on the x-axis. Okay, so if you want to find roots of an equation for which you have drawn the graph, so sometimes it's not always the case. But if you're given this equation and then they just put equal to 0 at the end, that means that take your roots on the x-axis. So we'll be taking this one root, and then we'll be taking this other root here. So you define. This means that so from here you can say x equal to minus 1, or here it's 3. Okay. So the interesting thing about this is that there's no difference. There's no difference between using a graph and actually doing the calculation. The answers that you get are either the same or they're close. Okay, so I'm going to do this for you quickly and then see if we'll get the same answer by calculation. You're not supposed to do it by calculation, obviously, but let's just test. Okay, so here we're saying equal to 0. If you factorize this, you'd use x minus 3 and x plus 1. Okay, two numbers that you would multiply to get negative 3 and add to get negative 2. So it's minus 3 minus 3 plus 1. Okay, when you add this you get negative 2, and when you multiply them, when you add this you get negative 2, and when you multiply them you get negative 3. Okay, so here you'd actually get x minus 3 equal to 0, or x plus 1 equal to 0. That means that x is equal to 3 or minus 1. And then the interesting thing now is that these are the same answers that we got in when we're using this graph. So what it just tells you is when you're doing paper 2 and then you're done, maybe you're really fast, you can actually go back and then test some of those things to see, okay, is my answer correct or something like that. Okay, so this is how you test it. But let's move to second question. So second question, it's drawn for us again, and this time we asked the same question at first. So we asked you write down the turning point of the graph. So the turning point again, this one is called a minimum. Sometimes a parabolic graph can have a maximum. It is a maximum when this one is negative, but it's not really necessary. Okay, but essentially this is the minimum. This is the turning point where the graph turns, where the graph changes direction, where the gradient changes direction. Okay, so this one here you have to investigate the coordinates again. Okay, so it'd be how many times are you moving from the origin? You're moving 1 unit in the negative. Okay, so negative 1, and this one is negative 6, and then you're done. Okay, so use the graph to find the roots of the equation. The equation now it's written as x squared plus 2x minus 5 equal to 2. So we also do, later on we'll also do calculations on our gradient as well, to just see the gradient, and also how you can do it using a graph. So but then right now this is just an introductory video, so that you familiarize at least with how to draw and also how to evaluate simple things like roots. So for our case here, what they did was, our original equation was x squared plus 2x minus 5 equal to y here. So they actually replaced y with 2. So if you want to find the roots, you find the roots at y equal to 2, like this. This is the line where you find the roots of this equation for the. So you go to y equal to 2, it's this line here. Okay, so you have 2. Then you just wait a bit, I have to rotate this. So you have to be careful. Okay, you have to get exactly where it crosses. So it crosses here and here. So we're also going to do by calculation and see if our answers will match. Okay, but essentially this is it. And now we have to read the points. So this point here, the roots would be x equal to, this point here it's showing this is 1, so, and 4 sub boxes. Okay, so this from here we get 1, so they are counting it as 0.2, 0.2, 0.2. So 4 sub boxes would mean 0.8. So it's actually 1.8 here. Okay, and then the other one, or x equal to, this one would be negative 3.8. So negative 3.8. So you can actually, if you are in an exam, so you can actually investigate this real quick. But then these are our answers, okay? So after you're done, maybe you have some extra time on your hands. This is how you'd verify it. So you have x squared plus 2x minus 5 equal to 2. So you push this one to the other side. So you get x squared plus 2x. This one goes there. So it becomes minus 7 equal to 0. Okay, done. After this now, you say x equal to negative b. So negative 2, negative b here, plus or minus. So if you want, you can even put brackets here. Square root of b squared, which is 2 squared here, minus 4a, which is 1, c, which is negative 7. Okay. All this we're supposed to divide it by 2 multiplied by a, or a is 1 in this case. Okay. So I'm going to rub some part. Let me rub this part here. And once I rub this part, I get this is x equal to, this is negative 2, this is plus or minus, this is 2 squared, which is 4. Then here it's minus 28 minus minus 28. Okay, so it's negative and negative, then you get positive. So it's actually 4 plus 28. 4 plus 28, you get what? You get 32. Okay, square root over 2. So now x is equal to either negative 2 plus square root of 32 over 2, or 2 plus 2 minus, rather, since we took plus the time, so we have to check minus this time. So over 2. So you just go on your calculator and then you see for the first root what do you get. So for the first root we have negative 2. So let me see new calculator. So negative 2, then we have plus square root of 32 divided by 2. Okay, so we get around 1.8. You see, so this one is actually giving you 1.83. So 1.83 here, which is very close to what we got from the graph. Okay, so now we are going to put minus and then see how that will pan out. So minus, and we get negative 3.83. So on this one, we get negative 3.83, like this, which are these answers, they are very close to what we got here. So that's the moral of the, on my working. What I was trying to do is to show you how you can use a graph to attain the same thing that you would have otherwise got if you had just used either factorization or the quadratic formula. Okay, here we use the quadratic formula. If you don't know how to use the quadratic formula, then we'll also do some examples later on to actually apply the quadratic formula. But essentially this is it. And remember, the thing is, the important message that I told you is that you're not supposed to verify your answer in the during your exam. So after you are done with everything, so you make it through the first part and then you have chosen your questions accordingly, you are done now, you're revising. That's when you start now saying you won't go and then check for if you got the coordinates right here. Okay, you just go and then see what is it exactly that I was supposed to solve for, and then you'd solve it using calculation, and then you check how close were the answers that I got. If you got close answers, then that's good, you can move over. Okay, so you have to be smart about it. This one, by the way, I actually realized that it was cut out a bit, but the equation was x squared plus 2x minus 5 equal to 2. Okay, let's move to the last question. So last question, this one we actually have to draw. So this one, it's a bit exciting. So it's a bit exciting. So we have to ascertain the coordinates first. Okay, so we have to ascertain the coordinates. So the way that you do it is you say y. So you're doing this on a piece of paper. You say x squared. You say x. You say minus 6 here. Then here you say you can say y at the end. Okay, since we'll be writing the result here, so you say y at the end, and use your ruler. Obviously use your ruler. Come on, ruler. Yeah, this is good enough. So here you use your ruler, and now let's do it. Okay, so here we have -3 here. So we are saying -3 squared. Okay, so here -3, -6. What do you get? So here you get 9 minus 3. You get 9 minus 3. You get 6. Then minus 6. Then you get 0 here. Okay. So we're going to try for -2 squared, -2, -6. So here we're going to get 4 minus 2. We're going to get 2 minus 6. 2 minus 6 we get -4. Okay. So let's try for -1 squared, and then -1, -6. So -1 squared, you get 1, minus 1, you get you're going to get 0, and then minus 6. 0 minus 6, you're simply going to get -6. Okay, let's try for 1. So it's 1 squared, 1 here, and you can say plus here, it's still fine. Then here it's -6. So here you would get 1 minus the 1 plus 1, you go to the 2 minus 6, you get -4 here. So it's actually symmetrical. So you can predict here what's going to come next. It's going to be 0. Okay, just like what we're given here. But let's try for 3. So 3 squared, then plus 3. Then 3 squared, that's 9, plus 3, you get what? You get 12. Then 12 minus 6, then you get 6. Okay, so here you'd get 6, here you'd get -4 here, and here you get -4 here, and here you get, okay, so this one is supposed to be 0. On -2 it was supposed to be -4, and on -1 it was supposed to be -6. So this one was supposed to be -6. And then here -6, here 1, -4. Okay, great. So these are your coordinates. Your coordinates would be, I'm just going to, okay, let me not drop this part. What I'm going to do is to illustrate. So for example, this point would be read as -3, 0. So it actually get to -3 here, and to -3, which is here, and 0. It's this coordinate here. So what I want you to do is just put a dot here. Don't make it too big, okay? You have to increase your precision. If you make it too big, then it becomes a problem. Just put a dot, then you put a circle on it. That's how you mark your coordinate. Then here -2, -4. So -2, -4 would be this part here. So I'm just going to put a dot, and I'm going to put my circle here. That's how I draw it. And then -1, -6, so -1, -6 here. Great. And then 0, -6 should be here. Great. Then 1, -4. You see the symmetry that I was telling you about. It's actually symmetrical about this line. Okay, we're going to look at symmetry as well. If somebody asks you the line of symmetry, then what do you write? And then this is 2, 0, and then this is 3, 6. So you get 3, and then 6 would be somewhere here. Okay, I actually covered this part using the details here. I should have been careful, but essentially you get this one. And the way that you draw it, many people, different people, they find different ways that they feel comfortable, drawing a line. Essentially, it's supposed to be very similar to that graph that we saw in the previous one. So it has to be a parabola, and it has to be smooth. And you also have to expect where the turning point would be. So it would be somewhere here. This is where the graph will be turning, and then it's going back. Okay. So the way that I draw it, I would draw it this way. So this way, it doesn't have to be accurate, but you should try your level best. Okay, so it's going to pass through this way, it's going to pass through this way, and it's going to pass through this way, it's going to pass through this way. Okay, not very accurate because I'm not using really a graph. I'm better at it when I'm using graph. But then this one, the tools that I'm using, it's a bit tricky. But essentially, this is what you get. So now you're asked to find, to complete the table, and then you're asked to find the solution for the equation x squared plus x minus 6 equal to minus 2. Okay, how do you do it? Here it says equal to minus 2. So you take your ruler, and then you go to line minus 2. So where is line minus 2? It's somewhere here. Okay, so line minus 2, it's here. And what you do is scribe your stuff. Scribe your stuff. Okay. Then afterwards, you have to identify where your line crosses the graph. Okay, so your line crosses the graph here, and there you have to write your points here, and you also have to write your points here. Okay, so this is how we identify it. So they want to see if you have identified the points, so this is how you show them. Okay, so I had my ruler on, that's why I couldn't write anything, but essentially this is it. Okay, so now you have to write those coordinates. What are they? So b x equal to, so not necessarily the coordinates, you're just looking for the x values. You want the solution. Okay, so x equal to, this is minus 1.5. Since this is minus 1, this one must be minus 1.5. Minus 1.5 or x equal to, then this one would be minus 2.5. Then done. Okay, so that's it. Let's actually verify our answer using our calculation method. So you're doing this on the side, you're just checking was my answer correct. Okay, so x squared plus x minus 6 equal to negative 2, then you get x squared plus x minus 8. Oh, so no, it's not minus 8, minus 6, then plus 2, minus 6 plus 2, you get negative 4. Then you get negative 4 here equal to 0. Then x equal to negative b, which is negative 1. Then plus or minus square root of b squared, which is 1 squared, minus 4a, which is 1, c, which is negative 4 here, and over 2a, so 2 times 1 like this. Then you get negative 1 plus or minus square root of, then you get 4 by 4 here, you get 16, so 16 plus 1, then you get 17 here over 2. So you're testing for negative 1 plus root of 17, root of 17. So negative 1 plus square root of 17 over 2 here. So it's negative 1 plus square root of 17 over 2. Okay, so you'd get 1.5 thereabouts. So here it was supposed to be 1.5. Why was I writing negative 1.5 here? So you see here, this one is obviously 1.5. Okay, so here I'm getting 1.56. So accuracy was a bit janky, but I'm getting 1.56. So from calculation, I'm getting x equal to 1.56. This 1.5, it's okay. Okay, so if I was revising my work, then I could be saying, oh yeah, I made a mistake there. This one was supposed to be positive, and then I just corrected. And then we are trying for now we are trying for negative 1 minus square root of 17, which we get negative 2 we're getting negative 2.56. Okay, so which is close to this one. Then you'd know that you kind of did the right thing. And then if you're asked to find the line of symmetry, you just see the points here. They actually mirror around this central location here. So they mirror around here. Okay, so this is where you'd find your position of your minimum point as well. So this one would be your line of symmetry, and then what would you say? How would you define it? Okay, so this one would be your line of symmetry. So this line, how would you define it? It's line x equal to because it crosses here. It crosses at x equal to what? Negative half. Okay, so this one would be your line of symmetry. So this was just the introductory lesson we didn't do for gradients. How do you find the gradient? We didn't do also for some other stuff as well. So for now, this is it. This was just introductory. So thanks so much for watching. Make sure you like, share, and subscribe. And visit primaEd.com. Okay, we are having some quiz for every topic really. So we'll be stacking up. Right now we're working on it so that you can test yourself. You can go find very refreshing questions there, write your exams, and then compete with others on the leaderboard. Okay, so thanks so much for watching. Make sure you like, share, and subscribe. Yuba out.